Today we're going to learn about subtracting integers. Normally people do okay when they're just adding integers, and they even handle the different scenarios, but when suddenly they're thrown with subtraction, that's when a lot of confusion starts to happen. So basically what I've gone and done is tried to create all of these subtraction problems with one method that will work every single time with every single subtraction problem that you have. I call it the KCC method. It's short for keep, change, change. It's very popular. I didn't create this. I wish I could give the person credit that came up with it, that taught it to me, but honestly I can't remember their name. So here we go. Let's just take a look at 3 different subtraction problems, and let's use this method. It's called the keep, change, change method. This keep refers to your very first number in the subtraction problem. We're going to keep its sign the same. The change, the C right here, sits right over the subtraction sign itself, and we change it to a plus sign, and then we're going to change the sign of the second number. This is a positive 2, so we'll make it a negative 2. What's 5 plus negative 2? 3. Okay, so let's take a look at the keep, change, change method again. This is a subtraction problem, so keep the sign of the first number, change the sign of subtraction into addition, and is this a positive 2? Yes, so it becomes a negative 2 with that second change. Negative 6 plus negative 2 is negative 8. So basically all that we're doing with this KCC method is taking a subtraction problem and we're going to turn it into an addition problem, and then we do whatever we see with the addition problem. 5 plus negative 2 is 3. Negative 6 plus negative 2 is negative 8. That's it. Here's the last one right here. 3 minus negative 4. So keep the positive 3, change the subtraction to addition, and change this negative 4 to positive. What's 3 plus positive 4? 7. That's it. So to recap it again, basically the keep, change, change is the first thing that we do, and then we just follow the addition rules. Only do this with subtraction problems. That's very important. We only do this with subtraction problems. If you come in and try to change an addition problem like 3 plus 1, well, think about it. It'd be 3 minus negative 1. Does that help you? No. Technically it actually works, but I'm just saying we don't want to go and make things complicated. Only do this for subtraction problems. Let's take a look at why keep, change, change works. Well, it changed the subtraction problem into an addition problem by adding the opposite. So here is 3, let me make it like this. 3 minus 2 equals 1. We know 3 minus 2 is 1. Okay. If we changed it into an addition problem, we added the opposite of the second number. Let's see if we get the same answer. 3 plus, and that's a positive 2. This is a negative 2. 3 plus negative 2 equals 1. We took the subtraction problem and we turned it into an addition problem by adding the opposite of the second number. Now that sounds really complicated, but stop and think about this. Keep, change, change. We're keeping the sign of the first number, we're changing the subtraction to addition, and we're going to change the sign of the second number. And now this becomes that. So let's take a look at this. Negative 6 minus 2 equals negative 8. Doesn't look that easy, but if we follow the idea of keep, change, change, all that we're really going to be doing by following the simple little saying is creating a addition problem that represents that subtraction problem. We're going to be adding the opposite of the second number. So negative 6 stays the same. Subtraction goes to positive. Subtraction goes to addition, and this positive 2 goes to negative 2. And so negative 6 plus negative 2 mirrors this problem down here. That equals, same answer, negative 8. And so we'll look at this one more time. This looks like a hideous problem. Negative 4 minus negative 3 equals negative 1. A lot of people can't see that it would equal negative 1 by just looking at it. However, I think a lot of people when they look at -4 plus +3, go, yeah, it put me at -1. I think it's easier to see with this. So why don't we create an addition problem from the subtraction problem following the simple saying of K, C, C. And we're going to basically keep this sign, change the subtraction to addition, and then change the sign of the second number. Well, there you go. -4 plus +3 is -1. It works because we turn the subtraction problem into an addition problem just by adding the opposite number. Do you have to understand this? No, but I'm just trying to get you to see that it's not a parlor trick. This keep change method has a lot of important it just has an important effect on the math that we're doing. If we use the number line to try and understand it, that might help us see it a little bit better. Let's look at 3 minus 2. Okay, well, you know 3 minus 2 is 1. Let's look at it on the number line, though. Let's see, here we go. Here's 3. And when you take away 2 or subtract 2, and it's a positive 2, we would go 2 to the left, and that puts us at +1. So that makes sense. And let's go and see if our KCC works here. Well, 3 plus -2. If you're at 3 to start with, and now you're looking at it as if it's an addition problem, and we're going to add -2, we would still go to the left 2 times. So the KCC is working. No matter what we throw at it, this KCC is working for these subtraction problems. Let's go through and see if we can make sense out of this. 3 minus -2. We're at 3. Now, if I subtracted +2, we would go 2 to the left. This time, though, I'm going to be subtracting -2, and I would have to go 2 to the opposite direction. Well, that puts us at +5. And that starts to mess with people's head because usually you're used to going to the left. You're used to making it a smaller number when you subtract it. But remember, you've never subtracted with negative numbers before. So all I'm trying to get you to do is to see that really a lot of these headaches go away if when you see a subtraction problem you go, you know what, I have a simple rule. Keep, change, change. Maybe you write out the KCC for a little bit until you get used to it. But once you start getting into a rhythm of it, you go, let's see, keep it the same, change, and change the sign of the second number. What's 3 plus +2? 5. And that's what we just were looking at. So remember, use the keep, change, change when you see a subtraction problem. It changes it into an easy addition problem, or at least an easier addition problem. And it takes away a lot of the stress when you're trying to do these subtraction problems. Go ahead and try numbers 5 through 10. Pause the video, hit play when you're ready, and we'll show you the answers. If you're wondering where 1, 2, 3, and 4 went, that was on my previous video with adding integers. Okay, hopefully you're ready, and I'm going to do the keep, change, change method each time just so that way you can see it. Keep, change, change. 4 plus -7 is -3. Keep, change, change. Keep, change, change. Oh, that's easy. That's 10. How about keep, change, change again? Keep, change, change. They have the same sign, so we'll just add them up. Keep it the same for the answer. It'll be a -7. Here's a different one. Keep, change, change. -5 stays the same. Change the subtraction to addition. Change this to a positive. And now we have -5 plus 3 equals -2. This is all that we do because it's subtraction. Remember, don't do this for an addition problem. You don't change the addition problem. What we're doing is actually just using this to change the subtraction into addition problem. So -5 stays the same. That goes to addition. This goes to negative. Hey, it's -10. And I think you can follow along at the bottom with what I'm doing. So hopefully you had no problems with these practice and checks. Hopefully it's taken a lot of the mystery and frustration out of subtracting of integers. To recap, only use keep, change, change on subtraction problems. This is the only time you're going to use keep, change, change. After using the keep change change method, the reason it works is the problem's turned into an addition problem. We're adding the opposite of that number. If you don't change that second sign, if you don't do that second change, it doesn't work. So good luck. If you got any questions, let me know.